Hello children and welcome to St. Ursula Girls High School and Junior College Nagpur's online teaching module specially designed for Standard 10 under the able guidance of our dear Principal Ma'am Mrs. Rachna Singh. I, Mrs. Ashrita, will be your facilitator for the subject Science 1. We have already started with Chapter 2. In this module, we will deal with Mendeleev's periodic table of classification. Before we go into Mendeleev's periodic table, let us have a quick recap. We have learnt in the previous module that Doberanus' triad theory failed, but he was successful in inspiring a lot of scientists around the world. One such scientist was a British scientist, Newland. Newland's law of octave also failed. During this time, in the 19th century, somewhere in the eastern part of the world, precisely in Russia, there was a Russian chemist, Dimitri Ivanovich Mendeleev, who was also working on the classification of elements. At that time, around 63 elements were known. Mendeleev started reacting these elements with hydrogen and oxygen. Now the question that might arise in your mind is that why hydrogen and oxygen? These two gases were reacting with most of the elements. While reacting these gases with the known elements, he found that the elements and their compounds had certain similar properties. He started to group the elements having similar properties together. Let us consider an example. Let us take lithium and sodium. Both are soft and shiny. When these were reacted with oxygen, they formed oxides, while when they were reacted with water, they formed hydroxides. Both of these had similar properties, hence they were placed together in the same group. This is how Mendeleev started to table the elements. Another thing, also similar properties, he considered the increasing order of atomic masses while placing the elements in the table. And then he observed a fixed pattern. In that pattern, he observed that elements having similar properties were occurring in the same group after a gap of 6 elements. For example, lithium and sodium have similar properties, but sodium automatically appeared under lithium after a gap of 6 elements, that is 1, 2, 3, 4, 5, 6. Again, potassium has similar properties of the sodium and lithium. It also appeared under the same group after a gap of 6 elements. Not just this fixed pattern, but also automatically when he was placing the elements, the atomic masses were also increasing in a fixed pattern. For example, carbon 12, nitrogen 14.1, oxygen 15.99. Therefore, he said that he observed a repeating pattern of chemical properties of elements when arranged in increasing order of their atomic masses is periodic, that is, it comes after a certain number of period, that is, certain gap is 6 over here, or reoccurring. And hence he stated the law, which says properties of elements are periodic functions of their atomic masses. I repeat again, properties of elements are periodic functions of their atomic masses. And this is how Mendeleev's periodic table came into existence. This table has a unique design. Now let us study the unique design and the style of Mendeleev in the table. First, Mendeleev grouped the elements in vertical columns having similar properties and he named them as groups. Vertical columns having similar properties were named as groups, while horizontal columns having increasing atomic mass were called as periods. Next, Mendeleev was a total genius. He had left empty spaces in the periodic table. Can you guess why? These empty spaces were left for elements that were yet to be discovered. Yes, he left space for future elements. Not just leaving space, he also predicted few properties of those elements. For example, he named the element after aluminium as Eka aluminium. He named one element Eka boron and Eka silicon. Later on, these elements were discovered to be as germanium, gallium and scandium. That means his predictions were turning out to be true. One of such things is a property. He said that the atomic mass of Eka aluminium would be somewhere around 68.0 units. And actually Eka aluminium, which is now called as gallium, is having atomic mass of 69.7 units. His predictions were true. Next is noble gas. Yes, you remember the disaster that noble gas had caused during Newland's octave? But this time, the problem of noble gas was completely solved. Noble gas were easily placed without disturbing Mendeleev's periodic table. Now, if you observe very closely, you will see that few elements having higher atomic mass have been placed before elements having lower atomic mass. For example, cobalt has 58.9 atomic mass and nickel has 58.7 atomic mass. Cobalt is placed before nickel. Okay. Now, why was this so? This was because Mendeleev wanted elements having similar properties placed in the same group. Why? Because he wanted elements having similar properties placed in the same group. So children, these were the few advantages of Mendeleev's periodic table. Let us again go through it. First, leaving gaps in the periodic table for yet to be discovered elements. Second, provision to accommodate yet to be discovered noble gases. And third, ensuring that elements with similar properties stayed together. I know Mendeleev's periodic table looks perfect. In fact, it was one of the most successful periodic classification during its time. But did it have limitations? Oh yes, it did. The first limitation was between two consecutive elements, the mass difference was not fixed. For example, if you take cadmium and tin, the difference between cadmium and tin is 6 units. And in between, the element that is placed is indium. Similarly, when you consider antimony and tellurium, their difference is also of 6 units, but there is no element placed in between the two elements. The second is the discovery of isotopes. What are isotopes, children? Isotopes are elements having same atomic number but different atomic mass number. Look at this example of an isotope of carbon. The original atomic mass is 12 while the atomic mass of the isotope is 14. Both these carbons possess similar properties, but due to the difference of atomic mass, they could not find position in the same group as carbon. The last was positioning of hydrogen. Hydrogen showed properties both of alkali metals as well as halogens because it was a diatomic molecule and it also formed covalent compounds. Therefore, it was not sure whether to place hydrogen with alkali metals or to place hydrogen with the halogens. So children, here are the three limitations. Before we move forward, let us have a quick recap. Russian scientist Dimitri Mendeleev arranged elements based on similar chemical properties. He focused on how various elements formed hydrides and oxides. Mendeleev's periodic law states that properties of elements are periodic functions of their atomic masses. What are the strengths of Mendeleev's table? Leaving gaps in the periodic table for yet to be discovered elements. Provision to accommodate yet to be discovered noble gases. Ensuring that elements with similar properties stay together. Limitations of Mendeleev's table. Inability to predict the number of elements between two successive elements. Inability to place yet to be discovered isotopes in the table. And the dubious positioning of hydrogen. So children, although this classification was a huge success during that time, but was there a better classification than this? This mystery we will solve in the next module. Till that time, please go through this assignment. I am sure you will easily do this, and I am sure that you have been following my assignments. If you listen to this module closely, these answers are mostly there in the module. Mendeleev's periodic table carries 2 to 3 marks in your SSC board examination. So children, before I sign off, stay home, stay safe and save lives. Thank you for watching. God bless you all.